The world has changed dramatically in the last 10 years, from the rise of the smartphone to the move to the cloud to new uses of AI. How technology is being used keeps evolving, and it's not slowing down. Jason Hoffman is the chair of the board of directors and president and CEO of MobiledgeX, and on this episode of IT Visionaries, he explains why everyone is asking the question, what's next? And he explains the role edge computing will play in the answer. Enjoy this episode. IT Visionaries is created by the team at mission.org and brought to you by the Salesforce Customer 360 platform, the #1 cloud platform for digital transformation of every experience. Build connected experience, empower every employee, and deliver continuous innovation with the customer at the center of everything you do. Learn more at salesforce.com/platform. This podcast is created by the team at mission.org.
Welcome to another episode of IT Visionaries. I'm Ian Faison, Chief Content Officer here at mission.org. And we are at Edge Computing World with a special guest. Jason, what's going on?
Hey, nothing much. How you doing?
We are excited to have you on today. We're going to get into pathology and and technology.
Okay.
And a little bit about your background and all things MobiledgeX. So first, how did you get into technology?
I started out as a scientist, and if you go back at least long enough ago, the only people that really used computers were scientists and accountants. So to me, it was always technology as a tool. Like most people, at some point in your life, you get obsessed with working on the tool. So spend some time working on the tool.
So flash forward to today. For our listeners who don't know, what is MobiledgeX?
We're a company that was started in 2018 by Deutsche Telekom. We're focused on at least what we call the demand side of edge computing. We divide it as simple in sort of a supply side and demand side. And what I mean by that is supply side is the typical, here's my IT infrastructure, here's an infrastructure system, put it in a given location, all the infrastructure-y type things. On the demand side, it's much more about who's actually going to use it and what are they going to be doing with it.
Okay, so explain to me the demand side.
So on the demand side of edge computing, it's basically this question of who exactly is it for and what are they going to do with it and what's that consumption experience going to be. We found, for example, that many people in the space are spending a lot of time on the infrastructure side of it. For us, a lot of what we do is on existing devices, net new devices, what the actual use cases are going to be, what are the new sort of experiences that show up on these types of devices? How do they take advantage of what's in the network and in the infrastructure, and what do those new backends need to be, and so on. So we're a lot more interested in we're working on that side of things as a company.
Taking a step back, what is kind of the state of the edge? I know we've been talking about the state of the edge report, but in your perspective, like where are we at on this marketplace from a supply side versus demand side?
Well, there's a couple ways of thinking about it. So one is, you can use the edge word, but the question really is, what does not have a clear means of distribution, and where can I not pay or economically engage, right? So we of course know about public clouds and Amazon, Microsoft, Google. There's, of course, the internet that sits on top of it. It connects to mobile networks. It goes to devices and so on like that. And when you sort of think of the world in a very simple way, that you have clouds that connect to about 6 layers of infrastructure before they hit a device, all that stuff in between is what we call the edge. And if you look at where it typically is, it's typically in the guts of the mobile networks themselves. So first and foremost, it's about actually having a clear means of distribution and a way for people to economically engage in that part of the infrastructure, just like they do on clouds and just like they do on devices. Now, as far as the maturity level of that, it's very, very early. Ourselves within, like the Deutsche Telekom properties it's a couple of countries. It's a relatively small number of sites, initial sort of use cases and things like that. But, at least what the overall model is getting sort of tested out. But that's that one sort of perspective of just, there's some interesting sort of spots in the world that people can start putting workloads inside of, and then just making sure they're able to do that.
So what does, what does the current kind of landscape look like? Like how many of those sites are out there now? Like what are...
Yeah. So, I mean, if you look at, if you take, let's take a country like Germany as an example, because, you're thinking of something that's in, the order of 60, 70 million people. There, like the three public clouds have a total of 9 facilities, for the public cloud. So there's 3 availability zones for Amazon, 3 for Microsoft, 3 for Google. They're all present in Frankfurt. So they're all present in one city. And then when they go on to sort of like the network backbone from, say, a DT, that goes between Frankfurt, Hamburg, and Berlin. We have capabilities in those other 2 cities besides just Frankfurt. Those connect to then 11 locations in the top 11 cities in Germany. Things like the mobile core sits. That goes to like 900 access sites. It connects to about 40,000 towers. That then connects to, say, all the country's smartphones. And so a lot of what we sort of look at is those 9 public cloud locations and then going and having another 917 locations between them and the device themselves. And having this type of difference where in the case of, because technically and architecturally, there really is no distinction between cloud and edge. The only real distinction is that your stuff is off in the cloud. And, maybe the most detailed about where it is that it's in Frankfurt, or it's on the East Coast of the US, or it's in Virginia. You may know in a city or a state or, sort of a regional type level. In the case of like an edge location, you know exactly where it is. I mean, you can walk up and point to where the spot is. It in fact has a highly precise and accurate, GPS location. And there's like a reason why you're doing what you're doing in that spot. It's not okay for it to just, quote unquote, be off in a cloud, sort of somewhere.
Yes. What would the reason be for that? Like in that exact scenario, what would the reason for that particular spot?
Yeah. So it can range from, there's like a group of people there that are having a common experience that's best served from that same place. Now you see that in, say, things like, games like Pokemon Go, where somebody goes somewhere specific in a specific location to then play that together. Well, in those types of games, it makes sense for then the back end of those games to also be in that specific location. If somebody's coming and doing like a Minecraft Earth, where they're going and trying to design something that's supposed to sit in the real world, even though now it's digital, it makes sense for that, since it has to occur in a specific location, to also have its back end in a specific location. So you'll have examples like that. And those can range from performance reasons to a better quality of experience, overall for everybody. It could also have to do with regulatory things around data sovereignty or privacy, and the data has to stay there in country. So you have a wide range of reasons why. But it is as simple as, the second an application has to happen in a given place, it just makes sense that its back end is also as close to that place as possible.
So for things that are non-permanent, what about something like an event or Coachella or something like that? Would you have something out in the desert or any, what?
Yeah, because I mean, even if you look at it, so even today, whenever you have those types of events, usually a mobile operator brings in a bunch of trucks and parks those trucks there. And what's in those trucks is a totally mobile network. And it's used to basically boost the capacity up from that quite a bit. And then, all we're essentially saying is that, let's say, for example, a lot of people are taking video at somewhere like Coachella and it's getting uploaded to YouTube and sort of other things. There's the ability of if there's other compute capabilities present around there, then, people like YouTube, for example, could verify those videos and make sure they're okay. They could do it locally. They could reject things sort of here and there. We can guarantee some sort of chain of custody as it gets uploaded for content moderation reasons. It's just sitting there and saying that there's connectivity there today. There's a couple of little services there today, but if we actually went ahead and let other people do what they would like to do in those locations as well, then that's all that edge computing is.
So when you have, obviously the amount of humans that are going to be on Disney Plus, that are going to be on Netflix, that are going to be, streaming video and all that sort of stuff will increase, going to continue to increase. Probably, I don't know linearly necessarily, but probably in like the US, it'll probably be pretty linear.
Now they tend to, I mean, most of the still tend to, I mean, the funny part is whenever you build up more capacity, people just consume it more.
Yeah, that's a good point. Yeah. I just was imagining, I guess maybe that, people are already streaming a lot of video, but maybe not. Anyways,
you'd be. I mean, the thing is so just about everybody in the world does have a smartphone now. So if you're over the age of 15, you do have a smartphone, but everybody's definitely not streaming 4K video to it.
Yeah, good point.
I mean, so and the thing about it is, the networks, clearly the networks of today and the devices of today are good enough for people to talk to people. So you can have a real-time bidirectional conversation between two human beings, right? It's also clear that we know how to make the infrastructure of today good enough that web pages and videos load fast enough that people don't really feel like they're sitting there waiting. And then clearly we do things well enough where humans can look at something and rapidly learn it if they need to, or go through a longer learning process because they want to learn a language on, YouTube or something like that. But when you stop and you think, it's about it's about voice, it's about human vision, and then it's about human learning. And the internet and this infrastructure is currently designed to be fast enough for those things to happen. Now, when you start thinking about the human eye being replaced by a camera or a series of cameras, well, now we're getting to the point where the resolution of those cameras is higher than the human eye. It can see further out. So when you start thinking about 32K resolution cameras that can see a kilometer out, and you can still zoom in to 4K on that is a higher resolution than the human eye. And the second that has to occur faster than we would expect because it's trying to identify something and make a decision, then the current networks that are fast enough for the human eye aren't going to be fast enough for a computer eye. Similar things, most of the stuff around machine learning and AI today, a 2-year-old baby will learn something faster than a computer does. You can teach a kid how to play chess faster than you can teach a computer how to play chess still. So machine learning hasn't quite caught up with aspects of human learning. But as it does, then it means that this whole infrastructure that we've built is not going to be fast enough for those things. So as we basically start heading into a world where people are talking to machines and machines are talking to each other, and machines are actually using cameras as eyeballs to actually see things, and they're actually using computer brains to actually learn and make decisions in, and we're actually expecting them to identify things visually, right? All the computer vision stuff. And we're expecting them to learn and decide faster than a human would. Then the current infrastructure that's good enough for humans is not good enough for that. And that's some future state, right? And people very often in the edge and cloud conversations now, they'll talk about, okay, well, we need to get down to this latency. We need to do this and we need to do that. And it's like, yeah, we do. When this type of camera would exist for something like this, and when this type of thing would happen fast enough, then we would need something like that. A lot of it is just that sort of difference there. Similar thing when you look at video, we're still going to be consuming video, right? And you can think of things like augmented reality and mixed reality as us still consuming video, but it's just the characters coming in, and the background of the video is from the camera on the device. And what that means is then the video I'm watching is personalized for me, and I can interact with it. I don't have personalized Netflix movies I can interact with. The only sort of thing you can do there is, like some of the ones they've done where you can make a decision and get a different ending.
Yeah.
Right.
Bandersnatch.
Exactly. But that's the only type of personalization and interactivity you have in that mass generated content today. When you really start thinking about what are games and AR and MR and, everything like that, it is really literally just digital content that's coming down, but the background is coming from the real world. It's interactive, it's personalized, and you're actually meant to collaborate with other people around it. And those requirements are what exponentially increases the technology needs. Just like, hey, and make it interactive, make it personalized, make it here, make it there. That takes more work. And then, the software takes more work to do it. The backend infrastructure takes more work to do it, but it is that simple.
Yeah, we were talking to a technology leader at TE Connectivity about, autonomous, and you're talking about like each vehicle having all of these cameras, having
like 16 high resolution cameras.
Yeah. And all of the functional components of like the engine, all of the sensors and everything.
Yeah.
Like a car is more complex, a house is more complex. All of these things, you talk about IoT, but all of these things are extremely complex. Your house making a decision about like changing its temperature is nowhere near as drastic as like, a car swerving to avoid, a seagull or something like that.
Yeah. Right.
So if you have those machine to machine conversations that are happening now without a human being involved at all, what is the compute needed for those type of things to occur?
Well, I mean, so a lot of them, in that case, a lot of that is, say, in the car itself. The need for, something like edge and the network connectivity, it's always the difference between being like an individual and being a population. So the edge is not needed if only one car existed, and it just did everything it needs to do on the car.
Yeah.
The second you actually have to do traffic management, then there needs to be a place where that information comes to. So it's a similar thing. It's like if there's only one airplane in the world, you want to need air traffic controllers. But the second there's actually traffic and those types of things, you need air traffic controllers. Where do those exist? So they exist in a hub and spoke in different airports and so on, like that, distributed a certain way. Well, it ends up being the same thing around, the sort of needs there. Now a car, a car is now basically a 2-ton smartphone, with either an exceptionally large battery in it. There may or may not have a gas generator in it. So these things are cruising around, and they're basically 120 kVA rolling data centers, inside of them, so that you can actually put a lot of capabilities in a car. I mean, you can sit down and go ahead and have 20 terabyte storage arrays, 150 to 300 sort of embedded chips throughout. They're cruising around, at 150, 200 million lines of code on a given car, which is 10, 20 times the size of an operating system and everything else like that. And all that's going to be handled by the car. But it's a second you need some type of coordination, collaboration, some, like group type behavior, that then that sort of next layer of edge and cloud comes in.
And so would these like edge locations is it kind of like, chicken in every pot and an edge location in every town over 500 people? Like, what does this look like?
Yeah, I mean, in some ways you could, like, if you look at, from a mobile network standpoint, edge locations would basically be, wherever there is like a packet core of the network. And that tends to be in the top 10, top 20, top 50 cities, depending on how large a country is. It can then sort of go the next step where you can think of, every time you have these, 3,000, locations in the country where you can go and plug in like a Tesla car. Those actually have their own private network connectivity. They have local compute presence. They can do software updates off of those. You technically call that like a big private edge for that. So it's going to just depend. Now, and you asked this question somewhat earlier. I mean, when you look at, on one end, when you look at like clouds, public clouds, they tend to have basically a couple locations in a country at the most. And so, they're always going to be in like the low hundreds of locations. And then when you start looking at, well, what's needed to deliver, a large scale video streaming service? Well, it tends to be in the low thousands of services. I mean, low thousands of locations. And then as you head into, okay, across all the mobile operators in the world, how many mobile core sites are there and access sites? Now you're heading into the high tens of thousands to low hundreds of thousands of locations. Then we start heading into towers, where there's millions of towers with tens of millions of base stations and hundreds of millions of small cells it's connected to sort of billions of devices. So literally as you go through, you sit down and say, well, there's tens of billions of devices connected to, potentially like a billion base stations sitting on, 100 million sort of towers talking to, and you literally just sort of layer it down. So the possibility really just sort of comes down to, how dense does this all need to be? And as we go from tens of billions of device endpoints to hundreds of cloud locations, how many distinct layers do we need to basically scale the thing out? It's not rocket science on it. You literally go, can 100 things talk to 10,000 things? And if 10,000 things can talk to 1,000,000 things, and 1,000,000 things is enough to talk to 1,000,000,000 things, and 1,000,000,000 things is enough to talk to 100 billion things, congratulations, you have 6 layers to the infrastructure. But, like right now, there's tens of millions of base stations and millions of towers connected to hundreds of thousands of access sites. And if you want to do math, like if you want to be within a millisecond of anywhere in the world, then you need about 200,000 locations globally to do that.
And so is there going to be an explosion in, vendors that are creating that type of, and this is like the supply side that you're talking about, right?
No, because it's not like, if you look at, on one hand, we only have 3 public clouds, really. Yeah. Okay. And on the other hand, on the complete opposite end of the infrastructure, there's really only 3 companies that make 98% of the world's base stations. There's hundreds of clouds locations and tens of millions of base stations. The open question is, for all the stuff that's in between those, exactly who's going to do what, or because from a base station guy perspective, like an Ericsson, Nokia, Huawei, you could say, oh, we're just going to get a little more centralized, do the next layer in, or do clouds become a bit more distributed, or, sort of what? I mean, candidly, that's an open question. And it's different on a per country basis. China will be very different than Canada. Canada will be very different than the United States. The United States is very different than Germany. Germany is different from France. It's different than, there's those sort of distinctions. Now, what I do know is that, or at least what I think, is that the edge stuff will look and feel more like how mobile networks themselves have actually been rolled out than enterprise IT infrastructure.
Oh, interesting. Yeah, I guess that makes sense because of how the devices are connected to it.
Yeah, well, but also like clouds by definition, you go and you build a cloud. A cloud is actually meant to give the perception of infinite scale and resources and capabilities, right? If you're then going in a very distributed fashion where you're doing these individual points of presence, they're always inherently scarce. So like it's a fundamentally different operating model, economic model. How are you even gonna? We build these big data centers and stick all the stuff inside because then you only have to go to one place to change a bunch of hard drives. But if you go to side, you're going to stick 100,000 hard drives, not in one building, but in 100,000 distinct locations. Someone's got to get in a truck and go there, because you have these funny things like in the base station world where it used to be a $200,000 base station that cost $20,000 to install. Now it's a $2,000 base station. Guess what? It costs $20,000 to install, and if it breaks, someone's got to go out there.
Yeah, because the human capital that it takes to put those things in is not going to change, right?
No, not at all. No, and you'll have like in the case of like, rolling out LTE, for example, in a country like the US, you'll have 15,000 people running around in trucks, running up towers and screwing things in and going to the next one and doing that every day for 5 or 6 years just to basically build out.
For 5G?
No, that was even just what happened for LTE.
Oh, for LTE you're talking about.
Yeah. 5G, it's a little worse because it's inherently at the higher frequencies going to have to be more dense. So it means more sites. There's not enough people to install it, to really install it.
Interesting.
At least for the dense side. Now but that's why, for example, like T-Mobile in the US launched nationwide 5G on like a lower frequency.
Yeah.
Because then it doesn't have to be as dense and it travels further. If you go from like 600 megahertz and you go up to these like 36 gigahertz type frequencies, 36 gigahertz doesn't go through walls.
Yeah.
So it just needs to be present in more places and it's not going to do long form, but it's a bigger pipe. Switching
gears. So you've been, since leaving pathology, you've been part of, some amazing organizations, Ericsson, WordPress Foundation, and so on. I'm curious, like, how have you seen the industry evolve in terms of like, you said it's still pretty nascent right now. So what was it like, 5 years ago? What were some of the things that you were seeing back then that kind of were the signs that this was going to change?
I made the transition from being a bit more like an end user to being, I guess, a quote unquote vendor in about 2003 when, I was one of the founders of a cloud company called Joyent I was at for 11, 12 years or so. And of course, 2000, when the company was about 13 years old, we sold it to Samsung in 2016. So it's like, back in for a lot of Samsung things now. I would say that, even starting in 2000, the sort of like 2003, 4, 5, 6, 7 type time frame, it reminds me a little bit of right now in that nobody really, they sort of did, but nobody really anticipated the iPhone and the whole smartphone craze that would happen. And then just the fact that it would literally basically, people just don't appreciate that just 15 years ago, it was just like 150 million people that had cell phones. And then now it's literally everybody everywhere, not just has a quote unquote cell phone. They literally have the most personal of personal computers that's vastly more powerful than something that existed 6 or 7 years ago.
Yeah.
These are amazing computers, that we have today. The connectivity is pervasive and everywhere. And so, that sort of emergence of the iPhone and the smartphone as the killer device. And then the fact that having to quote unquote go mobile was even disruptive to younger companies like Facebook and Google and so on like that. And they had to respond to it. And then all the companies that showed up in 2007, 8, 9, the Airbnbs and Ubers and, everybody that's basically been, IPOing now as like large companies, you're sitting back to like 2006, 2007. I don't think anybody back then really realized that it was going to be as big as it really was, and now we're sitting here.
Or as fast.
Yeah, or as fast. Yeah. You sort of, but what you literally did is people say, just, sort of, go and it's a world with no Instagram, no WhatsApp, really no Facebook, no Twitter, no Uber, no, like none of these things that are, practically verbs and nouns now.
Also, just like that, so many companies essentially became an app company, right? It's like even their website like doesn't get traffic. It's like everything's
well, and then
through the app.
and then what happened in the IT world, if you would, quote unquote, is that you can think of cloud. The simplest definition of cloud is that it's just highly accessible, industrialized infrastructure. But that process of industrialization means that you have continuously improving unit economics, there's supply chain thinking, how you breaking down components, like just these two funny requirements of let's have highly accessible, meaning like even partners and third parties can use it, industrialized infrastructure. That those two things then change every non-functional requirement of the infrastructure. So how you do upgrades, updates, maintenance, this, security, all that gets changed, by these two things. And so, this idea that infrastructure is supposed to be highly accessible, it's easy to consume, and the idea that like a Moore's law type concept gets applied to everything. Because remember, it was just for the CPU. It was just for the CPU, not necessarily for the unit cost of a VM or, so on, but just the fact that you have this like exponentially improving unit economics across every measure was, definitely sort of, a big change for people. And now when we're sitting here today, I think the big open questions for me, on the infrastructure side, we're still very obsessed with sometimes, technologies that basically pop up. There's still a great degree of automation and optimization, and it's going to be a much more distributed system than we've seen before. And these are not easy things to do. It's not easy to automate, optimize, and be distributed in that. And in a lot of ways that, for example, when you think of edge, very automated, optimized because you have the scarcity model at the middle of it, and a massively more distributed system than anybody's used to. And, meaning that you're not going to be able, the human brain's not going to go and do a pull down menu and make a decision on where things go because not going to be able to do that well. And then there's this open question of like, is there a post-smartphone world? So because we see, for example, like most of us sit around and we stare down at our phones, but if we're going to start holding them more up because we're using the camera in it and we're having some interactive AR type experience on our phone, and then we turn it sideways again, so it goes horizontal, so we have a better field of view. If we start doing that, your arm gets tired. You get sick of holding up the phone, and I don't think we're gonna.
It's better for my scalenes because I feel like my head is down all the time.
Well, and I don't think we're gonna build selfie sticks that come out of our necks that you stick your phone on, so that it's a hands-free, type of experience, and it's a pretty small field of view for these things, right? So if those types of applications are showing up more and more on a smartphone, then you want it to actually be like hands-free, and you want a bigger field of view. And that actually means it needs to go from a smartphone to like a pair of glasses on your face.
Yeah.
And you don't want to wear a gigantic, nauseating headset and everything else like that. You want to wear like a cool-ass pair of glasses. Like Mission Impossible style glasses.
Yep.
And if you sit around and said like, oh, well, let's go from the smartphone as being that type of device to Mission Impossible style glasses. Well, I mean, that's a pretty far out type. Still not a device that's possible to do, sort of in that. But there's this sort of question of like, well, what's next? There's going to be something next. It could be glasses, headsets, there's a drone next, a car next, that next, I mean, everyone's got that. But, there's sort of this explosion of emerging devices. And I think we're in a similar period of time where, whether it be the next 2 years, 3 years, 5 years, 7 years, something is going to show up or needs to show up. It's basically as interesting as the iPhone was when it did.
You were a CTO for a long time. What's your advice for our listeners that are kind of sitting in the seat now, whether they be, co-founders or not, but that are the chief technologists of a company? For some companies, that's the CIO. For some, it's the CTO.
Yeah.
I'm curious to like, what's Jason's takeaways for how to do it the right way?
Well, I mean, first, don't ever have a strategy based on technologies.
Interesting.
So you want a strategy based on why you're doing something. And then as different technologies show up, you want to be able to slot them in. So like a good example of this is I'll sit there and talk to people and they'll say, oh, we're adopting AI and we've developed an AI strategy. And sometimes they're the same people that 3 years ago or 2 years ago were doing their blockchain strategy. I'm talking about this, and now it's an AI strategy. And so it's this type of thing where there's always some new technology that shows up, and then they feel the need to develop some strategy on it. And then 2 years or 3 years or 5 years later, they find out, well, it wasn't really this, and it didn't really solve that. And we thought it was sort of here, and we got enamored by this technology and so on. Yeah, you actually have to base your strategies on something you'd like to achieve. So for example, we could sit down and say, it's always a good idea to have a strategy around optimization and care. How are we optimizing each aspect that we do? And how are we caring for our customers, caring for our employees, caring for our partners? Well, machine learning, AI, big data, Hadoopy things, analytics, all those different technologies that have come and gone, they all have the same purpose. And the same purpose is they're part of an optimization strategy and a strategy on how to care for things. So what people really need to do is to develop technical strategies around why something exists. That's a long-term strategy. There can be something that you could sit down and say, for the next 50 years, we're always going to be working on optimizing what we do and caring for what we have. And as different technologies show up, we're going to get better at that. Similar things where, like in the case of like when the big blockchain hype showed up, well, the whole thing there is that the reason why you would do that is because you're actually trying to guarantee the integrity of everything that you're doing.
Yeah.
Right. And of course, sitting there and saying, well, file system checks the integrity of a file system. Okay. How does it do that? By looking at a Merkle tree of hashes. Okay. Well, like a transactional ledger in Bitcoin, what does it do? It's a Merkle tree of hashes. And it's like, okay, so it's not necessarily new tech or feels like new tech or something like that. But if you sort of sit down and you say, what data does the company have? And how do I guarantee the integrity of that data as it's actually handed off to different people and so on like that? Then you go, oh, it actually makes sense for us to use this technology at this point. Maybe there's sort of a gap here. And so particularly if you're in the business of not changing your strategy every 3 years, or you're trying to actually do something real and substantial and so on, then what I encourage people to do is to focus on why they're doing things and what they're trying to achieve, and then having a strategy around that, and then having the flexibility that you can modularize different data, different tech inside of it as you go.
That's it. That's all we got.
Yeah.
Jason, thanks for coming on the show. Appreciate
thanks
it.
for having me. And
I feel like we barely scratched the surface. We got to have you back because I appreciate the insights, and I know our listeners do too.
Anytime you want.
Take care.
Thank you.
IT Visionaries is created by the team at mission.org and brought to you by the Salesforce Customer 360 platform, the #1 cloud platform for digital transformation of every experience. Build connected experience, empower every employee, and deliver continuous innovation with the customer at the center of everything you do. Learn more at salesforce.com/platform.